Inequality symbols, interval notation, set builder notation, and graph notation. Okay, to start, there are 4 main symbols we use to describe inequalities. So the first 2, less than or fewer than. So for example, you can say 2 is less than 3, or 2 is fewer than 3. And the way you can remember it is this little symbol. Imagine it's like a mouth and it's eating the bigger number. So in this case, 2 is less than 3, or 2 is fewer than 3. But you can also write it the other way around. This you say greater than or more than or exceeds. So we could actually just flip this same example around and we can say, all right, that means 3 is greater than 2, or 3 is more than 2, or 3 exceeds 2. Okay? So that's greater than, less than. If we put a line under the symbol, what that means is, in this case, less than or equal to. So I could say something like, my age is less than or equal to 30. That means either I'm 30 or I'm less than 30. One of those. It's any number that's less than or equal to 30. Another way in English you can say that is you can say my age is not more than 30, or my age is at most 30. All of those phrases mean the same thing. Okay, the last symbol is just that other one in reverse. Okay. So the other one in reverse is just the greater than symbol. Okay, so for example, we can say my salary is greater than or equal to 1,000. Okay, means I could be earning 1,000 or more. Okay, another way in English to say that, besides saying my salary is greater than or equal to 1,000, we can say my salary is no less than 1,000, not less than 1,000, or at least 1,000. All of those mean the same thing. So let's look at some examples, and you'll have to do this a lot when you're reading word problems, is take English words and change them into mathematical expressions, especially to do with inequalities. So let's look at the first one. It says Joe's salary is less than Mike's. So I can say Joe's salary less than Mike's. Remember, the symbol will eat the bigger one and point to the smaller one. So Joe's salary is smaller and Mike's salary is bigger. Fine. Let's look at the next one. May's spending exceeded 500. I don't know if that's dollars or euros or but what is the point? Her spending exceeded. Exceeded means is bigger than. So is bigger than 500. Okay, let's look at another one. To ride the roller coaster, you must be at least. Okay, so this is an issue of English. At least means that's the smallest that it's got to be. You've got to be either 160 centimeters or taller. So that's the case where they can say to ride that roller coaster, your height has to be bigger than, or it could be equal to 160. So just remember the word at least. It also means greater than or equal to or not less than. Any of those phrases mean the same thing. You can retake the exam at most 3 times. So either the number of times you take the exam is either 1 or 2 or 3 times, right? So the number is going to be less than or equal to 3. So the phrase at most means less than or equal or not more than. Okay, so the room can fit not more than 100 people. So there could be 100 people. So let's call it the capacity of the room is going to be less than or equal to 100 people. We cannot have more than 100, but we could have 100 or less. Okay, he repeated his speech not less than 4 times. So it means it was at least 4 times. It could have been more than 4 times. So let's say he repeated his speech. So the number of repetitions of his speech were at least not less than 4 times. So at least 4 times, bigger than or equal to the number 4. Okay, lastly, I want to show you 3 different ways to represent the same inequality information. Okay, so for example, let's look at number 1. If they say x is less than minus 2. Let's go first to drawing a graph. I think that's the easiest place to start. So you have a number line, and you have the number minus 2. It says x is any number that's less than minus 2. Less than, usually remember, to the left, you're going to negative infinity, very small numbers. To the right, you're going to positive infinity, which are bigger numbers. So if they say we want any number that's less than negative 2, it means any number on the left of this number line to negative 2. Now, it can't be equal, so I'm going to put a big open circle there. It cannot be equal to negative 2. It has to be less. Sometimes some books, instead of putting the open circle, they put a round bracket. But that's how you would show in a graph all the numbers that work in that expression. So negative 3 would work, negative 4, any number that's less than negative 2. So that's the graph notation. I'll go over to the interval notation. The interval notation just says, hey, well, what's the leftmost endpoint of our set and what's the rightmost endpoint? Well, you look at the blue line, it will go all the way to negative infinity, and then it will stop on the right at negative 2. And we put a round bracket because negative 2 is not included in the set. It goes to like negative 2.1 or negative 2.0001, but not negative 2 itself. Okay, now set builder notation, in my opinion, is the easiest. It's just making this expression a little bit more fancy. We're saying it's the set of all x's such that, so that x itself is less than negative 2. So all 3 of those are ways of writing the same set of numbers. Let's look at another example. Example 2. Where it says y is greater than or equal to 3. Again, graph notation, in my opinion, is the easiest. You put the number 3, and it says y is greater than or equal to 3. So basically, we can have any number bigger than 3. That's moving to the right. Remember, the right is going to positive infinity. The left is going to negative infinity. We're going to be bigger than 3. And it says we could be equal. So I make sure to color in the point at 3. If you want to write that, sometimes books do a square bracket to show we are including the number 3. So if we're going to write that in interval notation, we say the left endpoint is 3. The right endpoint goes all the way to positive infinity. And with infinity or negative infinity, you always put a round bracket as if to show we will never hit infinity. We'll never get there. It just goes on and on forever. And again, the set builder notation is just a little bit fancier. We just say it's the set of all y's such that y is bigger than, greater than, or equal to 3. So numbers like 3.1, 4, 5, 20, all of those are in the set. I forgot to write the 3. Okay, last one. Let's pick another color. How about purple? So now we'll start on the number line again. Now we have negative 4 is less than w is less than 1. So the key points here are negative 4 and 1. Sorry, I meant to say less than or equal to 1. So if we were going to draw the set, it says w is in between negative 4 and 1. It's not included at negative 4, so it goes all the way up to negative 3.99999, but it doesn't hit negative 4. But it could be less than or equal to 1, so we can color that in. And again, you can put a round bracket or a square bracket. So if we were going to do an interval notation talking about this set, on the left endpoint, we say we're going from negative 4, round bracket because we're not including negative 4, up till 1. And we put a square bracket there because it could be equal to 1. And then again, the set builder notation is the set of all w's such that w is bigger than negative 4 and less than or equal to 1.